Okay, continuing on. So now when they say given a circle, well, we know what this circle look like really quick. Again, something to get familiar with. I'm sure you've seen circles, but maybe you've seen it this way, maybe you didn't. This is a circle centered at 1, -3, with a radius of 5. So you go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And if you draw that circle, it looks like this. So keep that in mind again. Now the question is not whether you could recognize this as a circle as is. The question is, would you recognize the equation to be of a circle if it's not exactly like this? Because that's something that's going to come up for us as we move on here. It says the bottom half of the circle. Well, the upper half and the bottom half have to deal with y, so you want to solve for y. So you'd say y plus 3 squared equals 25 minus x minus 1 squared. You squared both sides. And if I wanted to take the bottom half, I'm really taking the negative of the radical. And that would be my answer. This will resemble that bottom half. Starts with -3, and since this is always negative, we're going to find that bottom half. Versus, if they say find the right half, the right half has to deal with x. You're going to solve this equation for x. So you could say x minus 1 squared equals 25 minus y plus 3 squared. X minus 1 equals plus or minus the square root of 25 minus y plus 3 squared. And y would equal 1 plus or minus the square root of 25 minus y plus 1 plus 3 squared. And if you want to take the right half, you want to take the plus. And this is going to resemble the right half of that circle. So the question is not whether you could go from this to this. The question is, when you see this or this, will you recognize that this is a circle? On the long run, that's expected to happen. Not a whole bunch of those, but it does come up every now and then. This is something that's going to help us with applications. This is a must. You want to find a formula in terms of one unknown for starters. That is, a rectangle has a perimeter is 10 feet. Well, we know that is twice the length plus twice the width. Express the area. We know the area of a rectangle is length times width. That depends on two unknowns, length and width, as a function of the length. So as a function of the length of one of its sides, you pick which one you like. So let's say I want to get rid of length. This is where this first piece of information comes in handy. This is an equation. If I want to get rid of L, I could say 5 equal L plus W, and L will be simply 5 minus W. So I could say the area is actually negative W squared plus 5W. That is expressing the area of the rectangle. Instead of length and width, it's only in terms of width. I could have done it in terms of length as well if I want it. Similarly, I have a rectangle, and if the rectangle happens to have an area of 12 square feet, well, I know area is length times width. Express the perimeter. We know the perimeter is twice the length plus twice the width. As a function of one of its sides. So last time we get rid of length, let's get rid of width in this case. If I want to get rid of width, again, this is where this comes in handy. We know the width is 12 divided by L. Take this and substitute it for the width. And you would say the perimeter in terms of one unknown is twice the length plus 24 divided by the length. You could get a common denominator, but that's not necessary. Express the area of a square as a function of its perimeter. Well, now we're talking about a special rectangle. If this is S, this is S. Express the area of a square. Well, area is S squared. And we know the perimeter is 4 times S. So express the area of a square as a function of the perimeter. What we don't want to see side, we want to see the perimeter. If you tell me what the perimeter is, I could tell you what the area is. Well, since this is a function of S, I know that S is P over 4. Take this now and substitute it right there. And I could say the area is the square of the perimeter divided by 16. If you tell me what the perimeter is, square it divided by 16, that will give me the area automatically. Again, these manipulations are a must for applications that will be coming up. An open rectangular box, one of those, it's open. Whether it's open or not, that affects only the area or surface area. It doesn't affect the volume. Has a surface area, well, here we go, of 24 square inches. Has the length to be twice the width. Whatever the width is, let's call it X. The length is twice that. And let's call the height Y. Express the height of the box as a function of the width. Express the height of the box as a length of the width. Well, we know that the surface area is what? Area of the base, that's 2x times x. Since it's open top, there's nothing there. Plus, this side is x times y, and there's 2 of them. And the front is really 2x times y, and there's 2 of them. So the surface is actually 2x squared plus 2xy plus 4xy, or 24 equals 2x squared plus 6xy. When they say express the height of the box as a function of the width, we'll solve for the height, which is y. Of course, I could have called that h if I wanted instead of y, but the book does that. So I could say 24 minus 2x squared equals 6xy. Divide by 2. And I could say the height, which is y, is 12 minus x squared divided by 3x. And there it is. Another open rectangular box. They like those boxes. An open rectangular box has a volume of 27 cube inches, has a square base, so whatever this is, I can pull the height y, that's a good idea. So the volume is length times width times height, so I know that x squared y equals 27. Express the surface area. The surface is open, again this is open. Surface area is area of the base, which is x squared, plus this is x by y, and there's 4 of them. Express the surface area as a function of its base side, so get rid of y, that's basically what they want. And we could solve for y easily, that's 27 over x squared. Substitute that in here, and you're done. And you could say the surface area is x squared plus 108 over x. Again, you could get a common denominator, that's not needed. And last thing I want to remind you of really quick, determine whether a function is even or odd. If you remember, you throw a -n. If the negative gets absorbed, so if f of negative x equal f of x, then we say f is odd, f is even, I'm sorry. And if you get negative f of x, we say f is odd. So in this case, you throw a -n, and you simplify. In 2 steps, you're done. So you simplify. If the negative disappears, meaning if this is identical to what you started with, you say, hey, that's an even function. What's so special about an even function? It's symmetric with respect to the y-axis. What's so special about an odd function? It's symmetric with respect to the origin. Versus when I look at part B, I replace x by a negative. That's a negative x, absolute value of negative x cubed. Now what I do, I simplify. This is going to be negative x cubed, but the absolute value will absorb that, and that will be negative x. So I could say g of negative x equal, this is not what I started with. If I factor a negative out of it to check if this works, this is what I started with. So this is an odd function. Otherwise it's